So in this reading guide, I'm going to look at figure 1 and figure 3. Actually, I think that's all I'm going to really go over. So let's start with figure 1. So this is a really interesting plot. What they've done is they've taken all of the measurements for all of the individuals for their entire study, and they plotted it age, year, and total cholesterol here. And then you see this like blanket that's sort of laying in your graph space. And what they did is they more or less made a blanket out of those values. So you can see that there was a dip here in this space, there's a dip here in this space, it dips here, rises up here. So they sort of fitted this shape as best they could to most of the points, right? Then what they did is they took individuals, the individual measurements, compared them then to this shape, right? This shape now is your predicted value. Given a person of similar background, if you knew their age and their year, you could use this shape to predict their total cholesterol, right? So now they're going to look at their actual values and they're going to see, do these fit onto this shape or not? And of course, not all of them are going to fit on there. And the areas that they don't fit are the amounts that are called residuals. So for this value here, this red square down here, it's way down beneath this surface. And so its residual is going to be large and negative, right? It's difference between the expected value and the actual observed value, or the predicted value and the observed value. That's what your residual is. So what they're doing here is they're controlling for the effect of age and year on total cholesterol, because each of those could have a different impact, but consistent across people. So that's the purpose of this figure here. Okay, so then what they did, they're going to get an average residual for each individual. And that's what they're going to use to test for evidence of selection. So they're going to take all of these values, like for this red person here, all of those values. They're just going to take the residual, right? Not the total cholesterol, but the amount that it deviates from predicted. And they're going to get the average residual for that person. And that's the value that they're going to use in their further tests for selection. Okay, but now over here they have in figure 3 here, a separate graph, and this graph is different. In this graph, we're seeing total cholesterol plotted here against lifetime reproductive success. But I just told you that what they did is they actually compared residuals to lifetime reproductive success, right? So to be able to make this plot for you, they try to explain this in their legend here. What they did, they had to convert their residuals back into units of milligrams per 100 mils. And the way they did this is they added the mean value, right, the mean total cholesterol value to each residual for each individual, right? So we're going back here to our residuals and we're adding the mean now, and then they're going to average across all the samples to get a single total cholesterol value for each woman. And that's the value plotted here, right? So these women who had 0 children, right, are plotted here for their cholesterol level. So here's one woman of, say, 340 milligrams per 100 mils of cholesterol, and her lifetime reproductive success was 0. So they plot all of their people now in their cohort that they use. And then they get into this thing where they want to get a cubic spline. So here's where they're trying to show us the directionality and the strength of selection. This is their visualization of it just for total cholesterol. I believe that they must have some supplemental figures that could do this for all of the other values. If they don't, they really should. But I looked at the supplement briefly and I didn't see it in there. I guess I didn't look far enough. In any case, here we have it for total cholesterol, and what you can see is this line here, and you can see the dashed lines. But so how did they get this? So a cubic spline is like fitting a line across all the cholesterol values and average lifetime reproductive success. They use this cubic spline specifically because it's a it's a method where you can take the derivative of this line at any given point, and that derivative, of course, is going to show you directionality, right? So you're gonna answer a series of questions about these figures, and this directionality and magnitude of change is something you're going to want to be looking into. So let me just take a quick look. I wasn't planning to say anything about figure 2. It's going to ask you in the questions to think about these divisions, these up and down dashed lines that are separating the cohorts that they divided women into. This is actually not cohort. It's not original versus later cohort. This is secular demographic change. So this is where they divide women into time periods. So you're going to think about how they made those divisions and what you think about those divisions. I don't go ahead and ask you any questions about any of the tables in that worksheet. We will spend more time on tables in class. Now that you've got a little better handle on the figures, though, make sure you review these tables here and get some thoughts about what you think they're showing, so we can spend more time in class on that. So please come to class with your worksheet prepared, and we will have a great discussion about this paper.